we've got is a couple of functions, I think each of which we can handle individually. X squared, we won't have any trouble finding the derivative of x squared, right? No trouble there. The other one is the square root of 1 minus x squared. Now the inside function, 1 minus x squared, we can find the derivative of that, it's a polynomial. And the square root function, because that's x to the 1/2, we can find the derivative of that. So what we have is a product. So I hope you're thinking product rule. Product rule. Going to use the product rule to find the derivative of this product. We'll refresh our memories as what the product rule is all about. We haven't had that on a test yet. And then when we get at some point in the product rule, how does that go, by the way? Derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. That's how that goes. So at some point along the way, early on actually, we have to calculate the derivative of that second function. When it comes time to find the derivative of the square root of 1 minus x squared, that's when we'll have to use the chain rule. So the basic framework of this is the product rule. But because we have the chain rule, that enables us to take the derivative of the square root of 1 minus x squared, and we'll be able to plug that in at the appropriate time. So we're going to think of this as a product, and the second factor, when we have to take its derivative, we'll use the chain rule to calculate its derivative. So here goes. Product rule. Product rule. F prime of x equals the first times the derivative of the second. Now, I'm going to go ahead and write it as 1 minus x squared quantity to the 1/2. I'm not taking a derivative. I'm just rewriting it in a friendlier form so that when we get to the point where we take the derivative, it's easier using fractional exponents than it is dealing with the radical. So the first times the derivative of the second plus the second, 1 minus x squared to the 1/2, times the derivative of the first. That's the product rule. Basic framework for the derivative of this function. Now, derivative of x squared will be no problem, that's just 2x. But the derivative of 1 minus x squared to the 1/2 will involve the chain rule. It's the derivative of something raised to the 1/2 power. So if we're looking at that, thinking, what's the outermost function? The last thing we would do when evaluating that, the very last thing we would do, if we're punching that up on our calculator, is take the square root. If you want to plug in 0 for x, evaluate that at x equals 0, you would square the 0, you would subtract it from 1, and then finally, you would take the square root. So that's the outermost function in that, in evaluating that expression. So f prime of x equals x squared times the derivative of something raised to the 1/2 power. Here we go, chain rule. Derivative of something raised to the 1/2 power is 1/2 times that something to the negative 1/2 times what else? Yes, times the derivative of that something, which in this case is 1 minus x squared. So it's like we're just applying the power rule. 1/2 comes out in front. We subtract 1 from the exponent. We get negative 1/2. We keep the expression inside the parentheses the same, and then we multiply by the derivative of the expression inside the parentheses. Eventually, the next step, that'll be what? Negative 2x that we get down there for that. Plus 1 minus x squared to the 1/2 times 2x. Easy one there. No chain rule necessary. All right. It's about to get a little algebraically ugly. And I apologize for that, but the idea is a clean, neat final answer. But a little bit on the, a little bit of ugly algebra here. Got to take a derivative. Going to leave it in the negative exponent there. Maybe take the 1/2 out in front. 1/2 x squared times 1 minus x squared to the negative 1/2 times negative 2x. That's really all the excitement that's happening to that expression right there. Take the derivative of 1 minus x squared, you get negative 2x, plus maybe the 2x out in front of that expression, 1 minus x squared to the 1/2. I'd like to say, what's another obvious thing we could do here before I'd say what I'd like to say? Something that we're simplifying. We're definitely going to factor. I'm thinking the 1/2 and the negative 2. Something easy. What's 1/2 times negative 2? Negative 1. The 2's basically scratch each other out, divide each other out. So that'll be the negative 1 there. And also x squared times x. Looks like we get x cubed. So minus x cubed to leave that expression. Let me go ahead and do that much, and then I'll tell you what I'd like to tell you. Negative x cubed times 1 minus x squared to the negative 1/2 plus 2x times 1 minus x squared to the positive 1/2.
Can you say again where the x cubed came from?
Yeah, I lost it.
The x squared here times the x here on the end. I think we can multiply those together. That's x to the 1 and that's x to the 2. So add the exponents there, we get x to the 3rd power. X squared times x equals x cubed. Yeah. So we've long since taken the necessary derivatives. This is the derivative. These last two steps represent the derivative. I haven't made a mistake somewhere. I don't think I have. Let me know if I do. But a nicer way to write this would be factored form. Eventually, in the not too distant future, the next chapter, we're going to be interested in zeros of the first derivative. Values of x that make the first derivative equal to 0 give us horizontal asymptotes, places where a function may stop increasing and start decreasing, or stop decreasing and start increasing. Horizontal asymptotes aren't the only place where that happens, but it's a common place where it happens. So it's a common thing to take the derivative, set it equal to 0, and solve for x. It's a lot easier to deal with an expression set equal to 0 in an equation if it's in factored form, rather than right now it's the sum of two expressions. So I want to factor out a common factor. Now I see the x cubed and the x, so certainly x is going to be a common factor that we can factor out. But also we've got a 1 minus x squared to a power in each one. Now as a rule, when you're factoring out, suppose I have 4x plus 5x squared plus 7x cubed. Good enough, I guess. I would like for it to be more interesting than that. X to the 5th power. How about that? Does that look like a 5? No, it doesn't. It looks like an upside down 2. There we go. 4x to the 5th plus 5x squared plus 7x cubed. If you're factoring out the greatest common factor, it's going to be x to the what? X to the 2nd. The rule we use is go with the least of the exponents, because x raised to the least of those exponents is going to be a factor of all of them. If we go with the greater exponent, it won't be a factor. So we'll go with the least of those exponents. So here's the thing. 1 minus x squared is raised to the negative 1/2 there. 1 minus x squared is raised to the positive 1/2 there. A negative 1/2 and a positive 1/2. We want to go with the lesser of those two exponents. What's less? Negative 1/2 or positive 1/2? Negative 1/2 is less. So GCF looks like this. F prime of x equals x times 1 minus x squared to the negative 1/2. We have a common factor of x, and they each have a factor of 1 minus x squared to some power, and the lesser of those two powers is negative 1/2. So we're going to go with the lesser of those two powers as our exponent. And now, one at a time, we look at each of these expressions and ask ourselves, x times 1 minus x squared quantity to the negative 1/2 times what will give us that expression? I bet we need a negative sign. We need an x squared.
Plus 2.
And
Plus 2
plus, yeah, we're going to need a 2 there. times 1 minus x squared to what power, so that if I add negative 1/2 to that power, I get positive 1/2. Negative 1/2 plus what will give me positive 1/2? 1.
Do we have to write the 1 or no?
As long as you know that it's there, you don't have to write it. So I'm going to erase it. I know it's there. There. So 1 minus x squared. And then simplify what's inside the parentheses. By our choice of the exponents, because we went with the lesser of the two exponents on the x's and the lesser of the two exponents on the 1 minus x squareds, we get a nice polynomial on the inside. So we can simplify that, and let's see if we can. F prime of x equals, oh, wow, let's see. The x is on the outside. So I want to write x times, I'll stick with the brackets, I want the square root of 1 minus x squared in the denominator. Why in the denominator? Negative 1/2 is the exponent. So I shove it down to the denominator, make it positive 1/2, replace the exponent of positive 1/2 with a radical. And then if I can just combine like terms, negative x squared minus 2x squared, you see a negative 3x squared there? And then plus 2.